Welcome to Zyus classes. I am your physics mentor. From Oersted experiments, we know that a current carrying conductor, it produces a magnetic field. That is, a current carrying conductor, it produces a magnetic field around it. So there was another great scientist, his name was Michael Faraday. So he thought, if a current carrying conductor could produce a magnetic field, then why couldn't the reverse be possible? That is, why couldn't a magnetic field produce an electric current? And if that was possible, it would be a great boon to our mankind, because till then huge batteries were used to produce electricity. And if magnets could produce electricity, then it would be a great boon. So he did lots of experiments. We are going to start with Faraday's experiment. For that, here I have a solenoid and a bar magnet. Now we know that a bar magnet, it has a magnetic field around it, and the direction of magnetic field, it is from north pole to the south pole. Now I am going to bring this bar magnet towards the solenoid, and when the north pole of the bar magnet is brought towards the solenoid, we can see that there is a deflection in the galvanometer. What is a galvanometer? We have studied about it. A galvanometer is an instrument which is used to detect the presence of electric current. A galvanometer can even detect the smallest of the electric current present in the circuit. It also helps us to find the direction of electric current. So here, when north pole of the bar magnet is brought towards the solenoid, there is a deflection in the galvanometer. Now, when the magnet is stationary inside the solenoid, there is no deflection. And when I brought this magnet back, then again there is a deflection in the galvanometer. But this time the deflection is in the opposite direction. So, next what I am going to do is, I am going to bring the south pole of the magnet towards the solenoid. And again note the deflection. But this time, the deflection in the galvanometer, it is in the opposite direction as it was in the first case. That is, when I brought the north pole, the deflection was in one direction, and when I brought the south pole, the deflection is in the opposite direction. Now, when the magnet is stationary inside the solenoid, again there is no deflection. And when the south pole is brought away from the solenoid, again there is a deflection, but this time the deflection is again in the opposite direction. So here we can say that when there is a relative motion between a magnet and the solenoid, a current is induced in the circuit, right? When there is a relative motion between the magnet and the solenoid, there is a EMF induced in the circuit. This is called electromagnetic induction. That is, whenever a magnetic flux linked with a conductor changes, an EMF is induced in the circuit. This phenomenon is called electromagnetic induction.